students, welcome back to my channel Maths Made Easy with AB. In this video we will be continuing with the lecture on differentiation. So in the previous video students, I'll just give you a basic. If you have not seen the video, the basics will not do. So you need to go back to the previous video. You must see that video. I think it's hardly 20 minutes video. It is a basic on differentiation. You should know that and then come back and jump on this video. Okay. So in the earlier video we had seen the first principle method. We had seen the first principle method to find derivative of any function. Yeah. We had seen the first principle method to find the derivative of any function, which was limit. So f dash x is equal to limit h tends to 0 f of x plus h minus f of x by h. So we had seen this application of this formula, the first principle method or the AB initio method or the delta method to find the differentiation of any function. In this video students, our motive is to make things more easier. So every time you won't apply this formula to find the derivative of function. So there are some formulas, there are some basic differentiation formulas. So we will be getting into the basic differentiation formulas now, which one by one you need to note it down in your notebook, which you must memorize. It is very important that you memorize those formulas, because every time you won't apply this in your competitive examinations, right? So you need to memorize that formula before understanding the theorems of differentiation, which will also be covered in this video. So let's get started. If you have not seen this students, do see the video. And till now students, if you have not subscribed to my channel, do subscribe if you are liking my videos. If you're first time, see the video first and then understand what we have for you. So the first differentiation students, the first differentiation is of sin x. The first one is differentiation of sin x. So what is the differentiation of sin x students? Differentiation of sin x is cos x. Differentiation of sin x is cos x. Now students, basically let me tell you, I've already said before, d by dx of sin x, I can also write it this way, is cos x. So dy by dx. So y is sin x, correct? Y is sin x. I am finding dy by dx. So that's why I wrote it in this format, correct? So y gets replaced by sin x. So dy by dx of sin x is cos x, correct? It can also be written as f dash x, correct? Or it can be written as y dash, or it can be written as y1. These are or. So differentiation, so dy by dx or f dash x or y dash or y1 or d, whatever you write. So basically it makes the same thing. We're just finding the differentiation of it. Already discussed in previous video. Yeah. So that's it. So differentiation of sin x is cos x. Our motive is not to understand the basic formulas over here. Yeah. These are the basic formulas. Second, d of cos x. Differentiation of cos x is minus sin x. Differentiation of cos x is minus sin x. Third, differentiation of tan x students is sec square x. It is sec square x. Fourth, differentiation of sec x. Differentiation of sec x, correct, is sec x into tan x. It is sec x into tan x. Fifth is differentiation of cot x. Differentiation of cot x is minus cosec square x. And the sixth one, the remaining one, is differentiation of cosec x is minus cosec x into cot x. Minus cosec x into cot x. So students, I'll just give you one technique to memorize. So differentiation of sin x is cos x is minus sin x, tan x is sec square x. Understand, tan x is sec square x and cot x is minus cosec square x. So understand the similarity over here, sec x and cosec x. Okay, differentiation of sec x is sec x into tan x and cosec x minus cosec x into cos x. One most important thing, somebody sometimes get confused where minus comes, where minus doesn't come. So wherever there is a C, cos has a C, cos has C, there is a minus. Cot has C, it has a minus. Cosec has C, it has a minus. That's it. That's how you remember the signs. Sine starts with S, it is not C. So there is only plus. Cos starts with C, cos is starting with C, correct? This has minus. Tan, does it start with C? No, it starts with T, tan. So tan is positive. Sec, it starts with S, so it is positive. Cot starts with C, it is negative. Cosec starts with C, it is negative. So that's a simple technique, you can say, wherein you need to remember where the sign comes. So I think these 6, you are very much clear with these 6 formulas. Now let us now move into the inverse functions. So sine inverse x, so that's not in possibly in your 11th chapter, whatever, wherever it comes. So my motive is not 11, 12. My motive is to make you understand. So basically in functions later on we will see inverse functions. You can see inverse function, how to find inverse function and all. Therein you will get in some concept about inverse functions. And further how to differentiate it we will learn further. But let's make some. So that was 7th. Differentiation of sine inverse x, students. Differentiation of sine inverse x is 1 by root 1 minus x square. Differentiation of sine inverse x is 1 by root over 1 minus x square. Differentiation of cos inverse x is same thing follows, same sine rule follows. Correct? Sine rule means minus. C, you get a minus. S, you get a plus. So differentiation of cos inverse x is minus 1 by root 1 minus x square. Number 9th, differentiation of tan inverse x. Differentiation of tan inverse x is 1 by 1 plus x square. 1 by 1 plus x square. 10th formula, differentiation of let's make it cot inverse x. C you have, correct? So minus 1 by 1 plus x square. Minus 1 by 1 plus x square. The 11th formula is d of differentiation of sec inverse x. Differentiation of sec inverse. It is 1 by mod x into root x square minus 1. 1 by mod x into root x square minus 1. And the last formula is differentiation of cosec inverse x. Differentiation of cosec inverse x. So what is cosec inverse x, students? It is minus 1 by the same thing mod root x square minus 1. Same thing, only minus comes into the picture. That's it, students. So these are the formulas for inverse function, and you see for C again, whatever starts with C has a minus in the front. That's not the concept, but that's a way to remember. That is not a concept of mathematics, that is a way to remember. Somehow it is coming. Why it is coming, not coming, you can use the first principle method and you can solve it. You can use the first principle method and see why it is minus and not, correct? Next, the 13th formula, importance is differentiation of e to the power of x. Students, we have already seen y is equal to e to the power of x, yeah, y is equal to a to the power of x, y is equal to log x. These are the functions that we have already seen before in my series on play with graph. Students, I'll just write down so that this stays in your mind. Play with graph. Students, this series you need to study if you want to master mathematics in JEE Advanced and Mains. Play with graph series, students. It's a very, very important series of mathematics. If you understand play with graphs, I just guarantee you will not only do good in mathematics, you will also do good in your physics as well. Yeah, correct? And important for solving any conceptual problem that comes in the exam. I'm not going into the graph of e to the power of x. So this graph, these, so we had done several series what this graph represent, what is the inverse, how to find inverse of the graph, what is the graph of log x, what is e to the power of minus x, so on and so forth. So you need to know that in the video of that one, play with graph. So what is the differentiation of e to the power of x? It remains that it is. you can prove it also by first principle. Differentiation of a to the power of x, students. A to the power, e is Euler number, you know, log e, log x base e. A is any number, so differentiation of a to the power of x is a to the power of x into ln a, where a is greater than 0 if a is positive. Yeah, then the formula is d a to the power of x, a to the power of x. So it remains that it is e to the power of x is e to the power of x, a to the power of x is a to the power of x into ln a. Yeah. 15th, differentiation of ln x. Ln x is nothing. What is ln x, students? It is log x base e. It is log x base e, ln x. Correct? We have seen and known this before. If you are a viewer of my videos, you will be knowing this as well. So this is differentiation of ln x is 1 by x. The formula is 1 by x. If I take any random number log x base a, yeah, that was a special case. When a was equal to e, it becomes ln x. So basically, if a is equal to e, it becomes ln x, log x base e. Correct? Yeah. So what is differentiation of log x base a? It is 1 by x ln a. 1 by x ln a is in the denominator. Correct? Till here, students? So these were the important functions. Now let us see some more important problems. So till 16th we have reached. Let's see the 17th formula now. Differentiation of x to the power of n. So this is n into x to the power of n minus 1. This is the formula. N into x to the power of n minus 1. Correct? So basically n has to be rational over here. In this formula, n has to be a rational number. So you need to be careful with this. Yeah, n has to be a rational number. It cannot be irrational or others. Yeah. So what is happening? So this is a very important. So in the earlier video on this first principle method, we had solved x square. Y was x square. So what was dy by dx? So we had found out 2x, if you remember. So how we had derived it? How? So basically what you need to do is x square. So the number, the power is 2. So bring 2 in front. So basically 2n comes in front, 2 comes in front, x into 2 minus 1. 2 minus 1. So this becomes 2x. Understood, students, how we applied this? dx to the power of n, this becomes 2x. So say for example, y is equal to x to the power of 9. Y is equal to x to the power of 9. What is dy by dx? 9 comes out at the front, x into 9 minus 1. 9 into x to the power of 8. This is a very simple formula. So just I showed you the application of this formula. This was required a bit. Got it, students? So this is the application of this formula, but you have to remember that this n has to be a rational number. Correct? So now we have certain applications of this formula. So I'll write it 18, which you need to memorize. Differentiation of 1 by x. Differentiation of 1 by x is minus 1 by x square. Differentiation of 1 by x is minus 1 by x square. How it comes out? How it comes out? Let me just show it to you. So now you saw what? So can I write over here? Let me show. Differentiation of 1 by x. Can I write 1 by x as x to the power of minus 1, students? Can I write it this way? So differentiation of this d of dx x to the power of minus 1 will be what? Minus 1 will come in front, correct? And x into minus 1 minus 1. That's the formula, right? N minus 1. So n is minus 1 over here. So n minus 1. So this becomes minus 1 into x to the power of minus 2. So which is nothing but 1 by x square. Which is nothing but minus 1 by x square. That's the formula. So basically this is a derivation from here itself. This comes from here itself. I hope this is clear to you. Now say somebody says, what is the differentiation of root x? So that is also a differentiation which you need to remember. So what is the differentiation of, So I'll write it down, a 19th formula of root x, differentiation root x. So you have to memorize 1 by x is minus 1 by x square. So you cannot just come and apply this formula. It will take 30 seconds in your life. You don't have that 30 seconds, students, when you are sitting for examination. Yeah, correct? You don't have that time. So now d of root x is nothing but 1 by 2 root x, 1 by 2 root x, 1 by 2 root x, correct? So now how it comes 1 by 2 root x, how it comes? So it again comes from this formula. So can I write x as 1 by 2? Root x, can I write it as x to the power of 1 by 2, correct? So if I differentiate it, 1 by 2 will come in front, x to the power of half minus 1, which is nothing but half into x to the power of minus half, which is 1 by root x. So 1 by 2 root x, that's the differentiation. So this formula, this also comes from here, correct? This formula also comes from here itself, nx to the power of n minus 1. So it's a derivation of this formula itself. You need not remember, so you need to memorize this, is what I am saying, although I have written it as different formula, correct? Students, so a 17th, 18th, 19th, and students, number 20th, differentiation of any constant, say 2, 3, differentiation of 2 is 0, differentiation of 1 is 0, differentiation of any constant is 0. What's the logic? This also comes from here. How can I say that? Say for example, you have been given to differentiate 1. So can I write 1 as x to the power of 0? 1 is nothing but x to the power of 0. So 0, so if I differentiate it, what will happen? 0 will come into the front, x. So 0 into anything will become 0. So differentiation of a constant is 0. You need to remember this. So students, that's the 20 formulas that you need to be by heart with. You need to memorize these 20 formulas that I just wrote. Hopefully you have written down all the formulas. If you have not, go back, write it down in your notebook, and then proceed with further understanding. Yeah, students. So let me show you a simple application of this formula over here before we proceed into some rules and some examples. So say for example, the question is, if y is equal to 2 to the power of x by 3 to the power of x, find dy by dx. What is it? If y is equal to 2 to the power of x by 3 to the power of x, what is dy by dx? So it's very simple. Which formula will be applied over here? Can I write y as 2 by 3 upon x? Simple indices, or what, I don't know what to say over here. So y is equal to 2 by 3 to the power of x. Can I write it like this? Yeah. Which formula will be applied, students? Y is equal to this nothing but a to the power of x. And you know differentiation of a to the power of x is nothing but a to the power of x into ln a. So dy by dx will be a to the power of x. So this will remain into ln 2 by 3. This is the formula what we had seen. So this, applying this, you will get to ax, a to the power of x, into ln a. A is 2 by 3. So ln 2 by 3. So that's how the application is done. Yeah, basic, many questions you will get in RS Agarwal and all those basic stuff, your NCRT and all. So go through those basic examples and you will be perfect in finding basic differentiations. Now students, the most important part of differentiation comes in, wherein we get to see the theorems of differentiation. Okay, so now we will be seeing some of the theorems of differentiation. So this is the theorems of differentiation. Okay. So the first theorem is very easy. So if you have been given fx plus gx, differentiation of fx plus gx is nothing but f dash x plus g dash x. So independently you need to differentiate and you will get it. Correct? Same for minus. So if is fx minus gx whole differentiation, you have to do f dash x plus g dash x minus g dash x or whatever. Plus is plus, minus is minus. Correct? Students, very simple. Whole differentiation, if it is a sum, individually you will differentiate. Simple, easy. Yeah. Second, if it is fx into gx, differentiation of fx into gx, students. So this is the product rule of differentiation. This is the product rule of differentiation. This is the product rule of differentiation. So basically what you need to do is differentiate the first function f dash x. Keep the second function as it is. Okay? Plus leave the first function and differentiate the second function. We'll see an example. So fx into gx, the differentiation of this function is f dash x, differentiation of first function keeping the second function as it is, plus keeping the first function as it is and differentiating the second function, or whatever, vice versa, whatever you do, because it is plus in between, it will fetch you the same thing. This is known as the product rule of differentiation. Okay, students, the third one. I hope till here you are very much clear with the understanding of what is happening over here. Yeah. So let me not move into the third theorem. Before moving into the third, the quotient rule, let me tell you another important thing. Say for example, three function would have been given, f into g into h differentiation. So fx into gx into hx, 3 is given. So what you will do over here? Differentiate the first, leave the second and third, plus leave the first, differentiate the second, leave the third, plus leave the first, leave the second, differentiate the third. That's it. And so on, and so on. If there are 4, so do 3, differentiate the first, leave the other 3. Leave the first and third and fourth, differentiate the second, and so on and so forth. You understood it. So this is how it operates. This is the product rule of differentiation. Let's now move into the quotient rule. Let's now move into the third rule, which is the quotient rule of differentiation, which is also simple. Just you need to remember these rules, students, to solve, because every time you will not get a simple problem, differentiate e to the power of x. So basically there will be a chain of function, a big function will be given, and it is very much possible that you have to apply these theorems to get it into the answers. Yeah. So the third is quotient rule. The third is the quotient rule of differentiation. Okay. So basically it is fx upon gx, the differentiation of this, fx upon gx, the differentiation. So this will be, students, what? Differentiation of the first function, okay, into this one, the denominator gx, minus, you understood, leave the first fx into differentiation of the second divided by gx, the whole square of this, gx whole square. Did you get this, students? What you need to do is differentiation of the first function into leave the second function, minus leave the first function, differentiation of the denominator function g dash x, divided by whatever is in the denominator, whole square of that. Whatever is in the denominator, whole square of that. We will see example. We will see example of this also. Now let us move into the fourth theorem, which is the chain rule. Let us now move into the fourth, which is the chain rule of differentiation. Which is the chain rule of differentiation. Yeah, students, chain rule. So what does chain rule say? If f of gx, what will be the differentiation of f of gx? So f of gx will be nothing but differentiate the first function into, you have to get inside now, g dash x. Got it? differentiate the overall function now. So f of gx, so f dash gx, so f will be differentiated first, and then you have to get inside the function and differentiate. We will get to this, you will be seeing examples of what I mean by this. Say for example, you have further f of g of hx. I don't know how many I have given. Okay, differentiation of this f of g of hx. So one more function inside. So first the outermost shell you have to differentiate, f dash g dash hx. Got it? Into g dash hx into h dash x into h dash x. Understood? The outer shell is differentiated first, f dash into g of hx, that is, it remains, then f is moved out, g dash hx, and then ultimately the internal function hx. You also differentiate one more internal cell, which is x. Since x differentiation is 1, so we have not written it. So that is also there into 1. This division of x, correct? So if it is x square, it will fetch you 2x. Correct, students? That's what it is, what it means over here. Now we will be solving some important 4 or 5 numericals, so that you get well versed with the chapter on differentiation. So theorems is done. 4 theorems we saw some minus, difference, we saw product, we saw quotient rule differentiation, we saw chain rule of differentiation, how it is applied. Now it is turn to solve certain numerical problems. Okay, students, some numerical problems. First is, question is, fx is given as sine of e to the power of x, sine of e to the power of x. F dash x you need to find out. You need to find out f dash x. So it is a chain rule, students. So it is basically nothing but f of hx. F of hx. So what will be f dash x? So I'll just write it down over here. Let me just erase this part. So this is nothing but what? This is nothing but fx is equal to f of gx, correct? Where fx is sin x and gx is e to the power of x. So you differentiate the entire function. So f dash x will be what? Cos. Sine function differentiation is what? Cos x. So cos of e to the power of x into you have to differentiate the internal part, e to the power of x. So this will be e to the power of x. Cos of e to the power of x into e to the power of x. Got it, students? I hope this is clear to you all. So now say for example, if the question would have been and into 1 also, I said you have to get into this x also differentiation. If this would have been e to the power of 2x, say it would have been e to the power of 2x, then you would have got over here cos of e to the power of 2x into e to the power of 2x into 2. Why would have got into 2? Because 2x also you need to differentiate and get 2. Correct, students? That's it. That's the part. So that's the first question that we solved. Correct. The next question is, say for example, fx is equal to sin x upon x. The question is, fx is equal to sin x upon x. You need to find out f dash x. You need to find out f dash x. So what will be this? So this is basically a fx by gx, where fx is sin x and gx is x. So this is the quotient question that you have got. So what will be the formula? F dash x will be how much? Sin x you need to differentiate, correct? So it will become cos x and x will remain as it is, minus sin x will remain as it is, and you have to differentiate x, which is 1, divided by x square. Correct, students? You remember the application? Just the formula you need to write. What was the formula? The formula was f dash x is equal to, I'm not writing f dash x because there we had f of g, correct? We had f of g. What was the formula? Differentiation of this, f you need to differentiate, g you need to keep as it is, minus g you need to differentiate, f you need to keep as it is, divided by g square. So same formula we have applied. Same formula we have applied over here. This is the application of that. That's it. That's the simple question that you have got. Okay. let's now get into the third question. The third question says, if say for example we take fx is equal to x into e to the power of x into sine x, x into e to the power of x into sine x, you have to find out f dash x, students. So it is simply the the product rule. So f dash x will be differentiation of the first, so x differentiation is 1, keep others as it is, e to the power of x into sine x, plus keep the first function as it is, e to the power of x differentiation is e to the power of x into sine x, plus x e to the power of x remain as it is, and differentiation of sine x, which is cos x. That's it. That's the answer. E to the power of x sine x plus x e to the power of x into sine x plus x into e to the power of x into cos x. Students, I think till here it is very much clear to you all. We have seen now some rule, if you want to see, that is very basic, but still I'll just show it to you. Say for example, if fx is equal to e to the power of x plus sine x, what is the differentiation, students? F dash x is sum rule. So e to the power of x plus cos x. That's it. E to the power of x plus cos x, the sum, the first theorem we have applied. E to the power of x plus cos. So this becomes individually. So differentiation of this was asked. So this differentiation e to the power of x minus e to the power of x plus sine x differentiation is cos x. That's it, students. Now let us see another good question. I'll not say it's a great question, but yeah, it's a good question. If fx is equal to x to the power of 4 plus x square plus 1 divided by x square plus x plus 1, find f dash 500. Find f dash 500. That's the question, students. What does f dash 500 mean? F dash 500 means find f dash at x is equal to 500. This means what? Find f dash x at x is equal to 500. So basically f dash x you need to find out, and then you have to put the value of x as 500. Yeah, you need to find out f dash x. Fx is given, you cannot apply 500 over here. F dash x you find out what is the differentiation of this function that is given, and then you put the value of x as 500. Students, I'll suggest pause the video, solve it on your own. So many of you might have paused the video and jumped onto a quotient rule. Apply this, see if it works for you. You are able to find out, you will definitely get the answer, but there is also a shortcut to find out. But you try it on your own, get to an answer, comment it, put it in the comment section whether you could solve it, you couldn't solve it, and then possibly I'll show you how to solve. So if you were able to solve it and identify the question at once, you are doing great. If you are not, I won't say you're not doing great, but yeah, this is one thing you need to learn. So basically there are lacks of concept, one cannot know everything. Yeah, so you need to just put in your brain whether you can simplify this. So I'm just giving you a hint. So that's the hint that I've given. Pause the video, solve this question, and then see the solution. Hope you have done the solution. Now get into it. So remember, students, x4 plus x square plus 1, x to the power of 4 plus x square plus 1, this can be written as, so I'm just writing it over here, x4 plus x square plus 1. Students, this can be written as x square plus x plus 1, yeah, into x square minus x plus 1. This can be factorized as x square plus x plus 1 into x square minus x plus 1. How it is being factorized? Should I show it to you? Let's show that also. So coming to here, so how did we get this? Let me show it to you so that you can always remember this. And you must always remember this function frequently somewhere, might not be in differentiation, but somewhere it comes, you just know that this will somewhat turn into this, the solution will need this breakup. Yeah, that's what my experience says. Correct, students? So can I write this as x to the power of 4 plus 2x square plus 1 minus x square? So 2x square minus x square is x square. Can I write this as this? Correct, I can write it, right? So this can be what, and this can be written as what, x square plus 1 whole square, students, x plus a plus b whole square, this one minus x square. Students, can I understand? So, s is x square, a square minus b square, so x square minus x plus 1, a minus b into a plus b. Did we get this? Did we get this, students? X square, so just opposite I have written, whatever. Yeah, x square plus x plus 1 into x square minus x plus 1. Got it, students? Yeah, so I am just erasing out this part. So, see over here how simple it becomes. Fx is equal to this. So, what will be f dash x, students? I am not coming to f dash x first. So, fx, I will simplify fx only. So, fx is x square plus x plus 1 into x square minus x plus 1. I can write it like that, right? Just now we saw x square plus x plus 1 is in the denominator, this and this will get cancelled out. What remains is x square minus x plus 1, and what will be f dash x, students? X square differentiation is 2x, x differentiation is 1, and 1 differentiation is, 1 is a constant, so 1 differentiation is 0. So, f dash x is 2x minus 1. Now, f dash 500. So, you have already found out f dash x. Now, you need to put the value of x as 500. So, 500 into 1000 minus 1 is 999. This becomes the answer of the question. Very simple, interesting question that you saw. Many would have taken a bit of time. Tell me how, if you got to this answer at once, or how much time you took to solve this problem in the comment section, students. If you have doubts, students, put it in the comment section so that I will try to solve it. Or you have my email ID as well. You need to just put your doubt over there. I will try and solve the problem, students. Yeah. So, that's it, students. Next question, let us solve one more question. The last one. If fx is equal to x plus 1 into x plus 2 into x plus 3 into x plus 4 into x plus 5. Correct? Find f dash minus 4. Find f dash minus 4. Students, whenever you get such questions, just understand that there will be some or the other concept involved over here. There will be some or the other concept involved over here. Okay? You need to understand that there will be some or the other concept will be involved over here. Yeah? So now let's understand over here f dash minus 4. This is a into b into c into d, e into e. Okay, students. So what will be f dash x? What will be f dash x? So it will be this differentiation into, it will remain as it is, students. So now understand, this is x plus 4, right? So differentiation of this is 1. So this is 1. And it will remain as x plus 2 into x plus 3 into x plus 4 into x plus 5. Correct? Plus this, the second will be differentiating this. So x plus 1 into x plus 3 into x plus 4 into x plus 5. Then this will be differentiated. Then this will be plus. So this is basically a product rule that we are applying. Fx into gx. Students, understand, everything will have a x plus 4. But the x, when you will be finding f dash x minus 4, this part will make the entire thing as 0, correct? Only that part won't be 0 which will not have x plus 4 in it. And that will happen when? That will happen when this part will, so basically this part will give you 0 because it has x plus 4. When, as soon as you put f dash minus 4 over here, so minus 4 plus 4, 0. So this entire part will become 0. But there will be one thing over here which will be x plus 1, x plus 2 into x plus 3 into x plus 5, wherein at that time you will be differentiating this, which will getting 1. This won't give you 0, correct? Rest all will give you 0 because everything has that unit x plus 4 with it. So f dash minus 4, this will be 0. Correct, students? Now f dash of minus 4 will be, so 0 plus 0 plus 0 plus 0. 4 units will give you 0, but the fifth unit, which is this one, will give you what? Minus 4 will give you minus 3, minus 2 and minus 1, correct? And minus 4 will give you plus 1. So minus 3 into minus 2 into minus 1 into plus 1. So basically this comes out to be minus 6 students. F dash of minus 4 is minus 6. I hope you are clear with this question. If you have doubt, you can ask in the comment section. If you have doubt, you solve the entire thing. You solved it plus, use the product rule and then apply F dash of minus 4. You will understand why 4 units will be giving you 0 and 1 unit will be giving you actual value. This is actually happening because x plus 4 is there. Minus 4 will give 0 in 4 units. Students, that's the basic of differentiation what we have done. We have understood the differentiation formulas. We have seen examples. We have seen theorems and application of these theorems. So basically in the previous video we had seen the finding out derivative using the first principle method. So this solves entire differentiation. If you have any doubt, you can just write down your question or whatever query you have. Go through the important books you have and solve it. I hope till now you have very much clear with it with the videos. Students, if you are liking my videos, do share, do subscribe and do like the videos. Do put in your comments if you have any doubt. Thank you so much for your time, students.